And so we've only got one topic left. So last time I left with you guys solving this problem here, right? This integral of cosine of square root of x. So today we're just going to use power series to evaluate limits. So again, the general rule of thumb is any kind of transcendental function is what you will plug in for. So x cubed and x here, we can just leave alone. We need to replace the sign of x. So to do that, we need to go to our power series sheet, which is right here. And the very top one is sine of x. So it gives you the closed form and it gives you the first couple terms. I'm going to take these first four terms for my limit. So I am simply replacing the sine of x with x minus, so let me just make sure I got this correct. So x cubed over 3 factorial, x to the 5th, over 5 factorial, and minus x to the 7th over 7 factorial. That's all sine of x. Then we have minus x and divide by x cubed. So if we realize we've got all addition, subtraction up top, the only reason I put the parentheses in the first place was just to, pinpoint that it's all from sine of x. We can get rid of those. They don't matter. And we have x minus x. So we can get rid of those. And then every one of these terms up here is going to be divided by x cubed. So this will be limit x approaches 0. Okay. And then if I reduce all of them, it would look like that. Then applying the limit as x approaches 0, anything that still has an x in it will go to 0. So originally, I was only going to take the first two terms of the sum. Does it make sense to you if I choose only the first two? Do you understand why I'm coming at it that way? So basically the first two would have been these two. Too early to be asking those kinds of questions?
Could you repeat the question again?
Originally, I was only going to take the first two terms for the sum. So just these two up here. I chose to take more because I wanted to prove a point. But would I have been okay to just take the first two or maybe the first three?
Yes, because it seems like anything past the, well, including the second term, will just be 0.
Right. Any term beyond the x cubed term, right? When we divide by x cubed is going to leave an x behind. So every single one of those terms, I don't care if I added the next 100 terms, they'd all go to 0 when I evaluate the limit. Let's see. I don't know. I guess I'll go ahead and do this one for you as well. And then I'll make up one for you to do. All right. So I have x squared I'm going to leave alone. And I have -1 that obviously I will leave alone. So I need the first few terms for e to the x, and I need the first few terms for cosine x. Well, e to the x is the sum from n equals 0 to infinity, x to the n over n factorial. And cosine should be x to the 2n over 2n factorial times -1 to the n. So let's check that. So cosine is -1 to the n, x to the 2n over 2n factorial. So we got that. And then e to the x right here is x to the n over n factorial. So it looks good. We chose the correct terms or closed forms. So let's write out the first few terms. So this would be x to the 0 over 0 factorial. And I think 3 will be enough. Let's see. And we'll do the same thing here. This would be okay. So that's 1 minus x squared over 2 plus x to the 4th over 24. And this up here is 1 plus x squared over 2. So I'm going to come back over here now to my limit, and I'm going to replace the x squared, or sorry, the e to the x by 1 plus x squared over 2. And then I'm going to replace cosine with 1 minus x squared over 2 plus x to the 4th over 24. So the first thing I notice is I can cancel this 1 and -1. And I'm not going to multiply that x squared in because everything in the denominator has an x squared in it. I'm going to factor that out. and then it'll allow me to cancel those. So I'm left with limit x approaches 0. 1 plus x squared over 2 all over minus 1/2 plus x squared over 24. If I apply the limit, x approaches 0, everything that still has an x will head to 0, and that'll leave me with this, which is equal to that. Any questions about those problems?
No, I'm good.
Okay. So I think they're fairly straightforward. It's just a matter of deciding what do I plug in for, and then once you have that decided, going back and getting the correct amount of terms that you need. So one of you requested that I look at quiz 21, right? So let me just open that. Come on. Okay. So the first part asks you to do the Maclaurin series, right? So let's just go ahead and do that. So f of x is cosine 3x, f prime is going to be minus 3 sine, right? Okay. Then for Maclaurin, we need these evaluated at 0. So the first one, or any of them that have cosine, the cosine of 0 is 1. So I'd get back 1, -9, and 81. And the sine of 0 is 0. Okay, then it says use the first 3 non-zero terms to write the function as a summation. So all that really means is write out your terms. So the first one plus, it would be 0x over 1 factorial. Then you'd have -9x squared over 2 factorial, and so on. So writing just the ones that survive, that's what I mean by 3 non-zero terms. Okay. And with that, we should be able to write a summation form. So this, instead of 9, right, this is really 3x squared over 2 factorial. And this is 3x to the 4th, right? Over 4 factorial. So you can say that we're having 3x to even powered, right? Even powers, because it's 0 for the first one, then 2, then 4. So even is represented by 2n. The denominator is also even numbers. It's 0, 2, and 4. And they are factorials. And then it's alternating in sign, starting with a positive. So if we use n and let n start at 0, this should work. So let's try the first two and see if it works out. So when n is 0, we get positive 1. Then we get 3x is going to be to the 0 power, so it's going to turn into a 1. And then 0 factorial, so everything is 1. So that's good. If we let n equal 1, then 3x squared is going to be 9x squared up here. Then you get 2 factorial, and negative 1 to the positive 1 is negative. So it looks like this is the closed form. Everybody good with that so far?
Mm-hmm.
Okay. Now the next part says, use the closed form from above and calculate this. So what I should have said was use these couple terms.
Okay, because that's what I did. And so what I did was, instead of using 3x, I wrote down, so I took the integral to the bounds of 0 to 0.5 of 1 minus 3x squared over 2 factorial plus 3x squared to the 4th power over 4 factorial.
Yeah, that was a lot of numbers. Give me a minute.
Yeah, sure.
So the other way to think of it is we've got cosine 3x, right? That's what this sum represents.
Mm-hmm.
And I'm asking you for cosine of 3x squared. So then instead of x in here, you're going to plug in x squared.
Mm-hmm.
And then write out the first couple terms. So that was probably left. I should have said maybe use first 3 terms or something. So this would be, let's see, let n equals 0. Everything's still going to be 1. Then you're going to have minus. You'd have that.
Wouldn't instead of 6, wouldn't it be 24?
Yeah, sorry. I did 3 factorial in my head for some reason. So that's what I wanted you to calculate.
And that's what I got. So I was just making sure because yeah, the question kind of confused me.
That was my fault.
And then you would just solve that integral, which is pretty easy.
Yeah, you just integrate and plug in.
All right, cool.
Any other questions about that quiz? How many others were confused by the question?
Maybe just me.
Well, I see some thumbs up and
Okay.
for some reason. So quite a bit of you. Okay. So I will certainly take that into consideration when I'm looking at it. Basically, that was me just trying to prepare you for something you might see for the test. All right, so I have finished everything that I had planned for today already. Besides, of course, reviewing. So hopefully you guys took a little bit of time yesterday to think about that, because I am now going to open the floor to you, all of you, to ask questions. And rather than me sit here and just talk to you for 2 more hours, I think I may solve a few problems, maybe give you a couple problems to do, and then if you still have questions, allow you to work them out with the group. Because it's always best if you do the problems. If I'm sitting up here doing it, you're just watching it. And that's how lecture goes a lot anyway. So I want you to get the most out of the experience. So are there any questions from the review that any of you can think of that you would like me to do?
Number 1B.
It says graph the first 5 terms of the sequence, then find the limit of the sequence if possible. Did you have trouble plotting it?
No, it's just kind of the ln, like the ln 1 over n kind of threw me off because in that case, I'm not quite sure how. Cause say like if you just leave it how it is, 1 over n is 0, and ln 0 or ln 0 is um undefinable or something like does not exist.
Well, the intent is for you to plot it first, right? And then rather than evaluate the limit analytically, to look at the graph and see where those points are heading.
Okay.
So I'm going to plot it here.
Now, can you still plot with the sequence mode on? So like you can go to y equals and it'll still show up on the graph.
Well, when you go to y equals, it's going to give you u of n.
Yeah.
And you can still plot. It's just going to be a discrete points, which is what a sequence actually is.
Okay. And so like there's like UN, and then there's UN min. Do we need to be concerned or worried about that? Like, would we only use the equals like we would only use UN?
N min, I always leave as 1, and then U of n is where you plug in the function.
Okay. And then below that, it's like UN min, which is like the third line from the top. What would that be? Is that just including the minimum, I guess?
I usually don't mess with that.
Okay, that's what I was asking.
Okay, so let me change my window here. So when I plot this, let's see if you guys can see these little discrete points. We'll see. Can you see those there? Point
Yeah,
there.
yeah. I got something a little different because it seems to be a straight line from me, but I might have plugged it in wrong.
Well, I think you're just like in a standard view. You got to zoom
Uh,
in.
Perhaps like what's your range for your x? Mine's like 10, -10 to 10. Should I make it like
Well,
say
for X, it tells you to do the first 5, right?
so like just up to 5?
So I did 0 to 5. And then for my Y scale, I did minimum -2 and max 0. And it looks to me like the points are heading towards -1.
Okay, yeah, I got you. Now any reason why you chose -2?
Well, I plotted it on the normal scale and then noticed all the points were below the axis.
Okay, so you kind of like close distance. I
I just
got you.
took the number to see if I could make it look good,
Okay,
make it work
yeah,
well.
yeah, I see it now. And they're all heading to -1.
So it looks like to me, yeah.
So in this case, you would say it converges to -1.
The limit is approaching -1.
Now that would be converging, correct? Like
Yeah.
okay, so and so for the test, say this on the test, you just write down the points. Say, therefore, it approaches -1.
Yeah.
Right? Sounds good.
All right. Any other questions you would like me to go over? Just a quick um, idea is at some point, I think we should look at these problems here, and I will ask you, um, tell me which type of series you think it is, or what you would use to solve it.
Mhm.
I think that's a good
Actually,
exercise.
um, I had a question. So I was working with a tutor the other day, and I was curious if I'm not sure if there's an official rule or something like that, but I noticed like anything with an n factorial in it, so say like m and n, um, I believe n used the ratio, if I remember correctly.
Mhm.
Yeah, and then n also used ratio. So is it that anything with an n factorial is probably going to be used with the ratio or root test?
Yeah,
Is
remember
there?
when we were working that out in class, and I wrote off to the side, ratio test is good for things with factorials.
Now, what about root test? Or is it because those tests are
The same, but root test is best used if everything is to the power n.
okay?
And of course, everything is multiplication and division. So for instance, everything here is to power n, but I would not use root test
Because you're adding the.
because you have a plus there and you can't take addition out of a radical.
Okay. Now I may be a little ahead, but it's just like, could we ask like what questions you're gonna be?
So we had like one like this in class where you had to rewrite that as a sum. So if you look at it, if you call these n, right, then this thing is the sum of 1 over n times the cubed root of n, starting at 1 and continuing to infinity. And you can simplify that, right, because n times the cubed root of n, so that's n to the 1/3, and the other one is going to be to the first power. So you add those, so you get 4/3.
Gotcha. That makes sense. And now I see where P series is coming from.
That one is a P series. Oops. All right, how about P?
Alternating.
Okay.
Looks like a root test.
You said root test?
I was gonna say
Yeah.
root test too, but it could be alternating.
I was thinking root test because everything's to the power of n.
Okay.
I was also thinking root test.
So root test sounds really good because everything's the power n. If you tried to do alternating, you would just end up with a sub n being 1 over the arctan to the n, which is doable, but I think root test is probably the better way to go. So this one you could actually do both ways, I believe. Let's see. What about F?
F. Couldn't you just? I forgot the name.
Is that telescoping? Because the denominator can be factored.
So I think telescoping is an option, yeah.
Test for divergence.
You could try that. I think that one's probably going to be telescoping. Let's look and see what it tells us down here. So F, yeah, integral is one. I was thinking maybe a partial fraction decomposition for that one. And this is a comparison test as well we could do. So let's see, is that factorable? Yeah, so that would factor. If we take the limit is n approaches infinity, it does go to 0. So yeah, you should be able to do telescoping for that one. Comparison tests would work nicely because you would choose these 2 points, right? Or these 2 values. And you'd have a p-series that converges that you'd be comparing it to. And then what was the other one it said? Integral test. So if we could factor that, like I said, you could do partial fraction decomposition, and then you could easily find the solution to the integrals. So any of those actually work for that one. What about E? Let's see, we've done F, we've done G. So we're talking about this one now. So it's kind of silly that it's written n squared over n to begin with, right? Because we can cancel one of those n's. So this is just the sum of n, which if I really wanted, I could write it as the sum of 1 over n to the minus 1. It's the same thing as n. And then what kind of series is that?
P-series.
All right, so that one's a p-series as well. All right, what about D? Nobody's got a clue?
Ratio test.
I just came back. What's up?
We're looking at part D.
Part D?
Mhm. I'm sorry, what did you suggest, Nick?
Ratio test.
Let's see.
Limit comparison.
Couldn't you do P
But I
series?
think it would be kind of ugly because you'd have to square the terms. Or at least you'd have to divide through by n plus 1 squared everywhere. Yeah, I think a comparison test would be a better place for that one.
Now, if you were to make it so change the equation to be 1 over n times n to negative 2 power, couldn't you make that into a P series?
Which one are you talking about?
E? Isn't that one that we are? Or did we already do that?
We did that one.
Which one are we on? I'm sorry.
D as
Nice.
in dog.
D. Oh, okay. Yeah, can you just do testified divergence? You just remove the. Actually, no. Then you have nothing left. No, you would. You would have. So say if you divide by n squared, you'll just have left over 2 over 4, and the 5 would just be 0.
Okay, but then what does that tell you from test for divergence?
Well, I mean, that'll converge to 2/4.
What I'm asking you is, what are the rules for test for divergence?
Um,
And anybody can answer that. It doesn't have to be Dan.
If the limit as n approaches infinity does not exist or does not equal 0, then the series diverges.
Okay, so it looks like we would get 1/2, which is non-zero. And so that would tell us it diverges. So it appears you could use that. I think it probably tells you to use a comparison test. Let's see. Nope, it does do test for divergence.
how about that?
All right. Let's try. Okay, so if you do D with test for divergence, what would you do C with?
Couldn't you do root? No, not root, because the addition.
I'm thinking you could probably use the same method, right?
That's what I was thinking, but I felt like that wouldn't have been the right answer, so I didn't say anything.
Well, yeah. Wouldn't it just be? So it's just ln over 1/2, which is. I'm going to type in the calculator.
It's like negative 0.69 something.
How about that? Yeah, you're pretty good.
I remember that one from like doing Half-Life formulas so many times.
So yeah, so then it would just converge to negative 0.69.
No, it doesn't converge.
Oh, diverge,
Diverges.
because it's less than 1. Gotcha.
It's something that's non-zero and it could be non-zero or does not exist. So basically anything other than 0.
Oh, so if it's less than 0. Gotcha.
Let's see. How about
What was the letter A?
A?
Mm-hmm.
Okay. Somebody want to weigh in? And not just go down to the bottom and look at the answer?
I would probably break it into 2 different fractions or and then do a root test.
So you want to make it,
Can you do that?
you can certainly break it into 2 parts. You're saying do it like this?
Yeah. And then since they're to the power of n, you could do the root test.
You could, but there's a much easier one here.
Oh man.
Do you remember the geometric series? Right, each one of them is a ratio to a power n. That's the geometric series. So you could treat both of them as geometrics. They're both have r's that are less than 1 when you take the absolute value, so they both converge. And if both of them converge, then the original does as well. Guys good with that one?
Mm-hmm. What about... Unless anyone else wants to do something. I was thinking... Which one haven't we done? Let's try J. That looks fun.
Let's do H first.
Huh?
Then we'll go J.
Wouldn't that be root?
No, definitely not. They're not power n.
Oh, that's right. That's I saw that and like, oh, there's no n. Okay, so that
Would you do the integral test?
Integral test, yes. Right, it's got the function and its derivative that appear. How about J, like Daniel had asked us for? So we don't have anything power n. We have a radical. So most likely I'm thinking some kind of limit's going to be had here. We could also take dominant terms.
So limit comparison test?
I think that might work well. What terms would you take for the dominant terms?
Three n cubed and 10 and n to the 10 over 3.
Right, it'd be n to the 10. You got to remember it's the third root, so n to the 10 thirds. Okay. All right, you guys pick one. You said letter O? Okay. All right. So what do you guys think for that one? Don't be afraid to be wrong. It's okay to be wrong now. Don't want to be wrong when it comes time for the test.
Maybe root test?
I think you could use your test, yeah. Because you could make it, you can make 1 to the power n, right? 1 to the n. Thinking maybe test for divergence might work for that one as well. So it says convergent by root test. So good. Right. Are you guys benefiting from this at all?
Yes, definitely.
How about n.
Isn't that E by a ratio test?
This is ratio test. What did you say before that?
Isn't that equal E?
I think you're thinking of this guy. That's
Yeah,
the-
but when you solve that, don't you get that form? Or am I thinking of something else?
I don't know off the top of my head if that comes out to that.
Could that look like one that we did recently when it came out to that?
It may be. But yeah, ratio test is good, right? Because of the factorial. About M.
Would that be alternating?
So you could do alternating because of the cosine n pi, but alternating series requires that you take a limit, and it might be a little strange thinking about factorial. Not really, but so this one I would say alternating, or because of the factorial ratio. Let's see. What about B? Somebody I haven't heard from today. I got to start calling on people. Gonna make me do it. All right, force on my hand. Garrett, B.
In the flesh. You said B?
Yes.
Isn't that geometric?
Right, you can do pi over 3 all to the n power, right?
Yeah.
All right, thank you.
Yep.
Q. Let's see who hasn't talked to me today. Ricio, do you want to do Q?
Um, root.
So I think if you tried to do root test, you'd have some trouble. Right, remember root test is good for when everything is power n.
Oh, sorry, no root. Yes, right.
No need to be sorry.
I think telescoping.
Telescope, right?
So I think if we factor it might be telescoping.
Mm-hmm.
Okay. Thank you. Let's see. Brennan, can you tell me L? Are you there, sir?
It's maybe a root.
Again, remember arctan to the arctan of n is not to the nth power.
I think it's alternating.
So it's definitely an alternating series. I think that's one way to approach it. Off the
Won't
top.
it be divergence?
What's that?
Won't it be divergence?
No, I think it's going to be convergent.
So if you do the alternating series, you'd first have to prove that it's decreasing. And I don't know what 1 over the arctan off the top of my head looks like. Oop, gotta fix my window. Or maybe it just doesn't want to plot this function at all. All right, my calculator's crapping out. Anybody have an idea of what 1 over arctan looks like? Do Desmos real quick.
Is it 1 over arctan is 1 over pi over 2?
When you take the limit, yes, but we also have to prove that it's decreasing. So to do that, I always tell you to graph it. So I see somebody drew. Is that an accurate depiction?
Yeah.
You didn't sound so confident there.
It is this.
All right, yeah, so I just plotted myself. That's good. So it is decreasing, and yes, you would get 1 over pi over 2 or 2 over pi. Now, because it's decreasing, it passes that portion, but the limit portion does not return 0, right? And that's the other requirement. So it looks like this is actually going to be a diverge, right?
Yeah.
All right, how many we got left here? We got I, K. Yeah. All right, so we'll do I, please. What test would you use?
Ratio test.
Certainly could do that. I think another choice might be a little bit better. So clearly it's not a root test, right? Because not everything's power n. Doesn't really look much like a integral test, right? It's kind of hard to do an integral of something power n or power x. And so if you're not sure what it is, we can at least start to eliminate some things. Doesn't appear to be telescoping, doesn't appear to be a p-series, it's not alternating, right? So we've eliminated a lot of stuff. I'm thinking a comparison or limit comparison would work really well.
Yeah, limit comparison.
I think that's probably your best choice, but that doesn't mean you can't use some of the others. Hopefully it's somewhat coming or becoming apparent to you as to how we choose which test to use. All right, last one. What would you guys do for that one?
It's alternating, right? This is the -1 to the n+1.
So the alternating is a great choice. I know a lot of people will try and say we could use the ratio test, but you have to think about the fact that in the ratio test, you'd end up with natural log of n+1 over the natural log of n. We don't really know how to reduce that very well. So I think alternating would be the best choice there. All right, so I would suggest, or what I think I would like for the rest of class is to maybe pick one of each of these types of problems that I know for sure you're going to see and have you work them out as a group. Or if you choose, I guess, on your own. But to ask questions and just make sure that you know how to go through the process. So I'm thinking this power series problem, the Maclaurin series, thinking one of these guys, be this guy, that should be good.
Quick question. So for 6 and 7, what type of questions are those? Just like, are they similar to the ones above, but does that approximate the?
It's
And those
approximating a series to a certain amount of digits.
and
And
so
what?
is that are those the ones like we find the left and right inputs, or that's the power series?
Those are the ones where you calculated the error.
Okay. Are those type of questions going to be on the test? Would that be
Did you hear me mention it?
um? You said something about evaluate the limit for another for power series or series problem.
It
So
even looks
disregard.
like a limit, not an integral, right?
Hmm?
So that's a limit, not an integral.
It's true.
So are you guys okay with my plan for you to try some of these problems? Yes, no, maybe. We don't care anymore. Just be quiet.
Sounds good.
All right, so do you guys need a second to write these down?
Yes.
Dr. Wilkins, can you solve quiz 16?
I have no clue how to solve it. I'm kidding. Yeah, I don't know what it is off the top of my head. Do you have it handy?
Yeah.
All right, so get those problems jotted down. There's also what, problem 3 I think I left behind.
I think you don't need to solve it.
You already figured it out?
Yeah.
Anybody else want to see it? or any of the other quizzes? Is that a thumbs up to C quiz 16?
Actually, wait, never mind. I'm sorry.
Okay.
Can we do number 6 of the exam review?
Can we do number 6?
Yes, please.
Of course we could, but I thought we established with my little chat there with Dan that it would not be the best use of our time.
Oh, okay. Thank you.
Is there any way that you can print out like or like send us like the worked out versions of these problems so we know how to do them, like for the 6 and the 5 and stuff like that?
For 6 and 5, you mean like problem 5 and 6?
Yeah. Just like let's say if we go in our own groups and we don't get these questions done, like if you posted like the steps to them, so like we know how to actually do it.
Well, I would hope that if you were in your group, that you would stick around until you finished it, if you're able to.
Hip. I'm just talking about the ones we're not doing, like as a group.
Well, the reason I picked these are the ones that you should be looking for come test.
Oh, okay, thank you.
All right, so I'm assuming you have them written down at this point. I'm going to go ahead and stop sharing. I'm going to pause recording.